Hi all. So in our today's session, we're going to be discussing in detail about virtualization. So in the first day of our class, we went in deep with the history of cloud computing, and from there we went to the services. And at the end of the session, we discussed about something called virtualization. So, what is virtualization? Why we have to go for virtualization? What's its key role in running cloud computing? So we're going to be seeing that in detail. So the basic terminologies we have to understand before moving into what virtualization is. Let's understand the basics that's related to applications. So what are applications? It's nothing but set of programs which are used for specific tasks. So say you're using Microsoft Office. We use Microsoft Office to edit our documents, store our files, and about whatever the data that we want to be available in the document format, we use Microsoft Office, right? So that's an application, which is again set of programs which is developed for users purpose. So it's available to the end user, obviously, not limited to that. So we have a mobile devices, and these mobile devices has n number of applications running on it, right? Example, we have WhatsApp, Facebook, Instagram, or Make My Trip, Red Bus. We have music applications. We have gaming applications. All these are applications which are basically viewed as set of programs which are getting the user's task done, right? So all these applications falls under what? SaaS, software as a service, of the services which is given to us, which is the IaaS, PaaS, and SaaS. And these applications, which are readily available to us to be accessed at any point of time, with just the connection of the internet to your device, you call that as the software as a service. What are APIs? See, APIs are nothing but application programming interface that act between the application and the services that you are willing to opt. So these are again piece of code which bridges the gap between the application. Say you are having an app which is say a weather forecasting app. So this works on real time, right? Every day it captures the data. It keeps updated you with the everyday weather messages. So whether it's sunny today or it's going to be rainy. So all those details would be given by your application, right? So there are some set of codes which are readily available, which acts as an agent between your applications. So every time you're accessing your program, which is your application, which is your set of program, there is gonna be again a intermediary program that will first get accessed before accessing your application. So your request first goes to that piece of program, and you call that piece of program as API. We have something called ABIs. So these are again set of codes or piece of codes on the machine level, not on the application level. If it is on the application level, you call it as API. If it is on the machine level, you call it as ABI, which are again your application binary interfaces. So it's on the machine level where one machine will communicate with the other machine in terms of exchanging zeros and ones in a specific pattern. So this is for the human readable purpose, and it's for the machine readable purpose. Okay, so with that, let's see a few more terminologies which plays an important role in the development of virtualization. So ISA. What is ISA? ISA is nothing but instruction set architecture. Okay, let's say it in simple terms. Say you would want to build a home or you want to build a shopping mall. What would be the basic criteria that we require to do it? We need the blueprint of the building that we're going to be building. So we need the measurement requirements, and we need the quotation, of course, right? Similarly, your computer system has its own architecture through which it will be exchanging information to and from the processor, to and from your machine to other machines in the internet. So basically, your system is designed as either 32-bit or 64 bits, which means your system is going to be using data packets which are going to be having combination of zeros and ones till 32-bit of combinations. So if it is 64-bit, you're going to be having combination of zeros and ones in 64-bit combination. Okay, now your hypervisor comes into the play. Your hypervisor is again called as virtual machine monitor, which is specifically used to form a layer on your existing machine so that the underlying machine's architecture is not confused with any of the architectures on the application that you're using on your hypervisor. Say this is your bare machine. What all your machine has inside it? It has a processor, it has RAM with it, and here comes your hard disk drive. This is your processor, this is your RAM, and this is your hard disk drive. Any machine you take will always have these three important computing resources inside it, right? I can call this as computing resources. Okay, so where is your OS? Your OS is sitting on this computing resource. So whatever the application that you're running, right? It's gonna be running on your operating system. Say MS Office, say MS Teams, say MP3 player. So this is your application 1, and this is your application 2, this is your application 3. Fine. So I have some amount of computing resource available in my local machine. I'm just gonna be installing few number of applications on my OS, but my computing resources are not effectively used, right? I might be having 1 TB of hard disk, I might be having 80 GB of RAM, I might be having a 8-core processor, but I am running just 3 applications on my operating system, which is proportionally equal to the wastage of my computing resources. So how do I efficiently use my computing resources? There comes the play of your hypervisor, the role of your hypervisor. What I'll do, I will install a hypervisor or my virtual machine monitor directly on my computing resources or hardware requirements that I have within me. So on this hardware, I'm gonna be installing my hypervisor, upon which I can have the eligibility to install as many operating systems as possible. Operating system 1, operating system 2, operating system 3. I can have two more operating systems simultaneously running on my physical hardware, upon which I can have again few sets of applications running on my operating systems. I can have Windows operating system here, I can have Linux here, I can have Ubuntu Linux Fedora here, I can have Ubuntu here. I can switch on between these operating systems as and when required. That's the requirement of hypervisor. That's why we go for hypervisor. So basically your hypervisor, what it does, it converts the architecture of your physical hardware Your physical hardware has a specific architecture which is totally intrinsic to it, and your operating system is going to be having its different design, its own architecture in it, right? So you're going to be converting, your hypervisor is going to be converting the architecture of your physical machine to the architecture of your OS. So the interaction in bits and bytes is going to happen with no confusion between the OSs that is running and the architecture of your physical machine. So that's about your hypervisor. So this pictorial representation shows you how your hardware looks like. So we have some set of instructions. We have the hardware has its own IO system, its own digital design, its own circuit design. So when you have your hypervisor on it, all these are encapsulated. All these are viewed as an abstract. Still, any number of applications with any number of configurations or any number of features or any number of versions that you're running is gonna get executed. So the second most important terminology is your system call. So what's a system call? Okay, so let's understand a system call first. Say I'm running my MS Office here. Okay, so along with it, I am playing a song in MP3 or VLC or anything. Say I'm working on a document. I'm typing a document here in MS Office. Parallelly, the MP3 song is being played to me. So at this point of time, there would be requests from my application 1 to the operating system, and from the operating system, it goes all the way to the hardware to allocate the resources to run my application. At the same time, parallelly, application 2, which is my MP3, is going to request the application operating system, and from operating system it goes all the way to the hardware. How is it going and what do we refer to as? That's a system call. So every time there is a request from the application, your underlying hardware decides which request has to be served at which point of time. So who does that? There is an important person, the boss of your operating system, which is called kernel, which is a highly privileged code. It cannot be accessed by all the processes at any given point of time without it being a supervised request. So your operating system takes care of all those activities. You don't have to worry about it. All we need to know is who is responsible for it and what are the codes that's related to it. It is again in C. So the request that comes from various applications will be handled in form of system calls by your kernel. So it is a highly privileged call which is enabling the user to access storage, hard disk, computing resources, RAM. Say for example, a user would want to insert a pen drive or he wants to insert his hard disk to his local machine when he is simultaneously working on MS Office and MP3. Immediately, the request would be given as a highly privileged option or a highly privileged request to the kernel. The kernel would be pausing it for a while, which will be in nanoseconds. So the user wouldn't even be able to identify it. So it will go to the kernel, and from there, immediately it will allocate the resources to access the hard disk drive. So all those has been given here. So requesting access to a hard drive like mouse or printer, creating and managing new processes, creating, opening, closing or deleting a file, and connecting to network, sending and receiving packets, all these are viewed as system calls. So there are some important system calls available in Linux and Unix system, approximately around 300, out of which we have fork and exe as one of the system calls which are most importantly and widely used. Okay, why do we have to know about system call now? As I had told you, system calls are the intrinsic operations that gets executed in your operating system for any task that gets executed. Similarly, when you have an hypervisor that is sitting on your hardware and splitting your resources into n number of resources, there are calls exchanged between your application and your hardware. So you call those type of calls which are totally controlled by your hypervisor or your virtual machine monitor. You call it as hypercall. You can see the picture here. You have your host computer system which is going to be having the hardware, that's your processor, RAM and storage, upon which I have a virtualization layer which is done by whom? Your hypervisor. So upon which I can have a guest OS. The OS which is already installed in your system is called the host OS, and the OS which is put on your hypervisor is called your guest OS. You can have as many number of guest OS possible, depends on your local machine. So on your guest OS, there's gonna be n number of applications running, right? So A1, A2 to AN. So all the requests from these applications will go all the way to your what? Hypervisor. It has to go to the hardware. So from there it will come to your hypervisor. The hypervisor will do the allocation task. So it will take care of which request from which application has to be directed to the hardware at which point of time. Okay. Now we are directly going to virtualization. As you can see here, you have a specific hardware which has some specifications already inbuilt in it. You're gonna be installing your hypervisor on it, and this is going to be giving you virtual environment to store your application, to develop your application, to host your web page, etc., etc. So you call that as a virtual machine. Say, you have Google, right? There are millions of users who have logged into Google at different point of time. But given at any point of time, Google has not shown that the server is down or it is off. See, it is storing your data. There are databases available to load your data. It is giving you security features. It is isolating your data from other users. It is giving your own privacy. It has its own access management, authentication, and authorization process, right? All these data are stored in the server ultimately, right? The server is going to be hosting it for you. But no user's data is interfered with the other user's data, right? How is the server managed? So there are millions of users and millions of servers hosting your data, right? And you cannot allocate a dedicated server for a single user in the globe. If you are going to be dedicating a single server for a single user in the globe, there are millions and millions in population, and you cannot allocate or you cannot build data centers as and then, right? That much data, that much amount of database or your servers cannot be scaled up. So how is Google managing it? They have their own dedicated servers which are virtualized. So they have their own hypervisors for managing the database, a dedicated hypervisor for managing their logs, a dedicated server for managing their security mechanism, a dedicated server for managing their applications, right? So what helps that? Virtualization helps with that. So it started in 1960 by IBM, which could be viewed as concurrent execution of multiple OS. As I told you, in a OS, there are various processes running, various applications running, right? Your virtualization is backbone of your cloud computing, which enables multiple OSs to run on a same physical machine. So your virtual resource could be viewed as, or it will be viewing your physical hardware as its own resource. So every application that is running on your OS thinks as though the whole physical machine is all for itself, but actually it is shared among all. So let's take a real time example. Say you are staying in an apartment. Say there are some 100 flats in your apartment. You're staying in block A, in your room number or in your flat number 001, 002. There are 100, right? 100 in number. So if you're staying in 001, you cannot think that the entire apartment is all owned by yourself. You occupied a specific or a given place or for whatever you're paying, and you're gonna be staying there. The same way, all the processes are not totally occupied to all the resources. At a given point of time, a specified amount of space is given to it to get its task done. So who does that? Your hypervisor. So when your hypervisor does that, what's the output? That's your virtual machine. So your virtual machine is again viewed as a combination of your OS, your application, and the virtual resources. So you have a virtual layer which is going to be totally managing your physical hardware. So who does that? Hypervisor. We just discussed about it. Is also called as virtual machine monitor or embedded monitor or embedded hypervisor. So it's again a software, or it can even enable it through your hardware. These days all the laptops comes by automated enabling mechanism. So the latest available softwares all has the hypervisor. You have to enable it by when your system is switching on, you have to go to BIOS. So when you go to BIOS, there would be an option called a hardware assisted virtualization, which is hardware assisted virtualization. So there would be an option called VTX. You have to enable it. So enabling your virtualization from the hardware level itself. So only if you enable it, you are telling your system that whatever the hypervisor that you're gonna put on your system is to be allowed to provision any guest OS on it. So you have a traditional system. Say you have an enterprise or you're running an enterprise. You're buying. So you're building a startup. You're buying all the hardware resources required to run your startup. You're investing on it. So you're buying the CPUs, the monitors, the database, your data connectivity, your network, and all those. And then you have to hire the employees to work in your in your startup. And then you will have to make sure that your employees are using appropriate licenses for the software that you're hosting. So whatever the OSs that you're using, the databases that you're using, you should be having the proper license for it, and upon which you will be working on the developmental jobs. You will be developing your applications on it. So this is a traditional system where you are investing from your own pocket. Say this is taking 20 crores. Say after some years, you have to compete with the market. You would want to scale up the resources. You want to increase the number of hardware. You would want to purchase more operating systems, advanced versions of operating systems, and directly proportional to the development of your application. Again, you will have to invest, say, 1 crore or to 3 or 4 crores again on that. This is called a traditional infrastructure of hosting a data center. See, not all your hardware will be used, or not all your software licenses or your softwares will be used at a given point of time. So sometimes it will be underutilized, sometimes it will be overutilized. You might even require more hardware later after 2 to 3 years of time. So this can also not give any dedicated servers to a specific operation. Say you would want to manage your mail system, you would want to manage your firewall service. You cannot dedicatedly give a server to all the mail managing system all by itself. So if you have some amount of core, if you have some amount of GB, if you have some amount of hard disk drive, only 30% of it is utilized. And if you have firewall and if you dedicatedly give a server to it, only 6% of it will be utilized. So in such cases, what you would do is go for virtualization. Host a dedicated server which is going to be having with some specification of core, RAM and hard disk drive. Put your hypervisor on it and run your individual applications upon it, which can simultaneously and parallelly gets executed with the help of your hypervisor. And you can efficiently use your servers in your startup. So your capital investment is going to be high here, and your returns is not going to be as much as expected. But here, in case of cloud computing and virtualization, your capital investment is going to be very low, but your output is going to be really high. So there are types in hypervisor. The first one is your bare metal hypervisor or embedded hypervisor. The second one is your hosted hypervisor. Okay. What's the difference between a bare metal and a hosted hypervisor? You have your hardware already with you, which is your processor, a RAM, and your hard disk drive. So you're installing your hypervisor, which is your virtual machine monitor, directly on your hardware. Okay. And on that, you are running the guest operating system. You call that type of hypervisor as bare metal hypervisor or embedded hypervisor. On the other hand, you have the other type where you have all the hardware with you, upon which you have the OS first, and on your OS you install your hypervisor, which is a software which is going to be running various operating systems as well as the applications associated with it. You call that type of hypervisor as hosted hypervisor. When you're directly installing on the hardware, on the bare metal, you call it as the type 1 hypervisor. And when you're installing it on the existing OS, which is a piece of software, this is again a piece of software, but you'll have to enable your hardware assisted hypervising feature. Here you'll have to enable here again, but you'll be having a piece of software which is going to be sitting on the OS, and from there your guest OS will be operated. That's hosted hypervisor. Some examples of type 1 hypervisor: your VMware hypervisors like vSphere, ESXi, ESX, Microsoft Hyper-V, Oracle VM Server, and Citrix hypervisor. All falls under your type 1 hypervisor, which are bare metal hypervisor. These hypervisors are directly installed on your hardware. And you have type 2 hypervisors, which are VMware Workstation, VMware Fusion, Oracle VirtualBox. This is one of the simplest form of hypervisor we have, which you can just download the ISO image of this on your OS, install the image, follow the procedures, and boot the operating system whichever is available in your VirtualBox and work on the operating systems and install applications, and you can access it through your Oracle VirtualBox. And Solaris even provides its hypervisor in type 2 form, and we have Oracle VM server which is of x86 architecture. So benefits of using a hypervisor: you have n number of services running in the data center. All these servers could be consolidated, and you can have various VMs running on these servers, and your servers could be efficiently used without wasting the computing resources. So how would you access the server? You're not going to be directly going and working with the network, right? How are you accessing it? Microsoft Azure, AWS, they all provide it through something called the interface, the UI, right? User interface. So it's a web page. You're going to be accessing it through their web page. The dashboard is going to be showing you all the options. It's going to be easily accessible for all of us. You're going to be clicking few options over there, and your VM is readily available to you. What is data replication? Say I have a VM created in a data center, say in US East. I have another VM created in US Ohio region, VM2. The data stored in VMS is similar to the data stored in VM2. Say there is some natural disaster or some fire or some flood has happened, and this server is totally down. As a user, I am trying to access my VM, my data, but the server is down. The data is, my request is immediately directed to VM2. Still, I would be able to access my data. So you call this technique as data replication. Your data is present at a given point of time around various locations or various data centers, so that even if there is a downtime in one of your hardware or a VM, or there's a crash or a corruption or something has happened, there is other VM which is trying to help you out, which is trying to serve you the data. And to do that, you have something called data replication technique used by the hypervisor to store your data in VMs. And there's another option, the benefit, which is your resource optimization. We just discussed earlier, you have 1 TB of hard disk drive, you have 8 core CPU, and you have 16 GB of RAM, which is underutilized for just 3 applications running on it. So how would you optimize, how would you use the hardware efficiently? So in such cases, just install your hypervisor, distribute your work, and try to efficiently use all the physical requirement that we have. So desktop environment monitoring. So whenever you're accessing your data center or any server behind your data center, you would be given with a UI, which we just saw, right? What is this? This is a desktop environment mirroring, which is giving you a mirror of the desktop exactly as your local machine is looking like, right? So you can access your remote applications anywhere. It's just a replica of your physical desktop. So if you're working, if you're having a home office, if you're logging into your office from your home, you would be given with options where you can remotely log in and work on your applications, right? So you call such type of applications as remote desktop applications, which is enabled with hypervisor. So minimal downtime. So the user is trying to request the VM1. It is down. There are some hardware updates that's happening here. I don't have to wait for the resource to be served to me. I can immediately access it from the other VM. Even in case of natural disasters, cyber attacks, or corruption, or app crash, so virtualization always stays as a backup or a backbone for providing a seamless and continuous integration. So, so with that, I'm gonna stop today's session, and I'll continue the next session with the next topic, which is gonna be differentiating cloud versus virtualization versus containers. So see you all. Thank you.